It's important to understand that machines, even simple machines like this lever, produce a mechanical advantage. That means that even though you are placing a nut in either section A or section B, because of the lever action of these nutcrackers, you will actually be applying much more force to the nut than you would to the handles, which makes it much easier to crack the nut. Now let's take a look at the concept of actual mechanical advantage. You can see this example in your book. A loading ramp is a machine used to move heavy items onto a truck. The mechanical advantage of the ramp with a rough surface is less than that of a similar smooth ramp because of greater force needed to overcome friction. So the first thing that we're looking at here is the output force divided by the input force. If we come across a question that is asking for actual mechanical advantage, you know that you must divide the output force by the force that is put into it. A concept that is closely related to actual mechanical advantage is ideal mechanical advantage. Notice that the difference here involves input distance and output distance as opposed to force. Remember, two things involved always when we're doing work is force times distance. So actual mechanical advantage deals with force, whereas ideal mechanical advantage helps us with distance. Now, go ahead and pause the video and turn to page 425 and make sure that you understand the example that is given in the book for how to solve this problem. Okay, let's practice another example from page 425. This is question 1. I want you to notice what the question is asking you to solve for. We find it here at the end of the problem. What does it say? We're looking for ideal mechanical advantage. If you look in your book on the next page, on page 424, it gives you the formula for ideal mechanical advantage. Okay, the formula is this. Ideal mechanical advantage is equal to the input distance divided by the output distance. Now, all we need to do is go to our question and look for these two things. Okay, what's our input distance? 3 meters is our input distance. So we put 3 over our output distance of 0.5. And that gives us 6. 6 is our mechanical advantage in this question. Okay, let's take a second and do one more question together. Number 2 gives us this problem. Construction worker moves a crowbar through a distance of 0.5 meters to lift a load 0.05 meters off the ground. What is the ideal mechanical advantage of the crowbar? Okay, remember our formula. The ideal mechanical advantage is the input distance divided by the output distance. What is our input distance? 0.5 meters. What is our output distance? 0.05 meters. Now we just do division. 0.5 divided by 0.5 is 10. So our mechanical advantage is 10. Okay, the last concept we're going to look at in this section is efficiency. Efficiency is simply the work output divided by the work input times 100. Remember that because of friction, there will always be an efficiency below 100%. Okay, now let's see what you can remember. Go ahead and pause the video while you do this question on your own. If you guessed C, you were correct. Okay, pause the video one last time to do this final question to see if you understand how to do this formula. Okay, before I tell you the answer, let's make sure you did the formula correctly. Remember, the ideal mechanical advantage is equal to the input distance divided by the output distance. So what is my input distance? Now be careful with this question because the actual input distance is given second. How much is the lever being pushed down in order to raise the large rock up? The input distance then is 2, and the output distance is that the rock only moves 0.1 meters. That means the mechanical advantage is 20.